We are on to sulfur dichloride. Let's count up the number of valence electrons. Sulfur, group 16, has 6 valence electrons. Chlorine in group 17 has 7. And there's 2 chlorines, so that is 6 plus 7 plus 7. That's 20 valence electrons to work with. Let's put sulfur in the middle because it is lower in electronegativity. Put the 2 chlorines around it. Let's connect them with the bonding pair of electrons. That's going to use up 4 of our 20. We're down to 16. Let's get the chlorines, the terminal, more electronegative elements, atoms with the octet. So we can put 6 more on each because they already had 2 from the bonding with sulfur. So that's going to use up another 12, and we are left with 4. And we're going to slap those on the sulfur in the center. There's our valence electron. There's our Lewis structure for sulfur dichloride. Let's take a look at the VSEPR geometry. The formal charges are all 0, so we're good with that. Now the central sulfur has 1, 2, 3, 4 effective pairs, or regions of electron density. 2 of the 4 are connected to other atoms. In other words, 2 lone pairs. Alright, so you're not going to get this table on your test. You've got to remember these shapes. 4 regions. If they were all bonded to other atoms, it would be tetrahedral, but only 2 of them are, so it's bent. So let's redraw this using the line dash wedge or 3D. Alright, with sulfur dichloride. Alright, sulfur there. That chlorine is on the same plane as that chlorine. So I'll just use regular lines for that. Get those valence electrons in there. Now this one is, I'm going to use a wedge to indicate that's coming out of the screen in front of you, and I'll just draw that a little bit bigger for perspective. Wait a minute, this is a lone pair. We only have 2 chlorines. And then we have another lone pair going back behind the screen. Yeah. And so the bond angles are going to be a little bit deviated from the 109.5 because these lone pairs, especially the more closer they are, okay, so like since the parent bond angle was 109, there's more repulsiveness than it would have been, say, like 120. Then it would be very minimal repulsion. All right, so this is going to be less than 109 degrees. Less than, because you got 2 lone pairs with that extra repulsion. So the molecular geometry, to answer the question, is bent.